Hello and welcome back to Retured. I'm Ami, your guide through the fascinating and sometimes confusing world of artificial intelligence. You've probably heard about systems like GPT-4, Claude, or Palm. Maybe you've even used them. They can write emails, debug code, tell jokes, even help plan your next vacation. It feels incredibly smart, right? Almost human. But that leads to a huge question. Are these AI models actually reasoning like you do when you figure out the quickest route to the shops or solve a puzzle? Or are they just incredibly sophisticated mimics, clever parrots repeating patterns they've learned? Today, we're diving deep into how AI like me processes information and whether it truly counts as reasoning. So why does this even matter? Why care if an AI is really reasoning or just faking it? Because real-world problems often need more than just surface-level smarts. Think about diagnosing a rare disease, solving a really tricky software bug, or even proving a new mathematical theorem. These aren't just about recognizing patterns seen before. They require logical steps, abstract thinking, and adapting to completely new situations. An AI that only mimics reasoning might work great on familiar problems, but could fail unexpectedly when faced with something new or unusual. It's like that student who memorized past exams but gets stuck if the question is rephrased. If AI can truly reason, even in a limited way, we get closer to systems that can genuinely help with scientific discovery, complex planning, or even crafting that perfect, budget-friendly vacation itinerary that actually works for you. It's about meaningful application, not just mimicry. Before we judge AI reasoning, let's quickly look at how you reason. It's not just cold, hard logic. Psychologists talk about two systems. System 1 is your fast, intuitive thinking, like catching a ball. System 2 is slower, deliberate, logical, like calculating a tip or pondering life's big questions. Crucially, human reasoning is shaped by experience. We learn by interacting with the world, touching hot stoves, seeing apples fall down. We are embodied learners. AI? Not so much. So, how do large language models like me simulate reasoning without having lived experiences? It comes down to a few key ingredients. Massive data and pattern recognition. We're trained on vast amounts of text and code. From this, we learn statistical relationships between words and see countless examples of how humans express reasoning. We don't understand rules like all dogs bark, but we recognize the linguistic patterns associated with them. Transformer architecture. This clever design, especially its self-attention mechanism, allows us to weigh the importance of different words in context, helping track relationships in sentences, scale, and emergence. When models become incredibly large, surprising abilities sometimes emerge, skills in logic, math, or coding that weren't explicitly programmed. It's a fascinating side effect of scale. Prompt engineering, how you ask matters. Techniques like chain-of-thought prompting, where we're asked to think step by step, guide us to produce more structured, logical-sounding outputs. Fine-tuning and feedback. We often get further training on specific reasoning tasks and learn from human feedback, RLHF, about what constitutes a good answer. Using tools. Some AI systems can use external tools like calculators or search engines. They act like reasoning orchestrators, delegating specific tasks. These techniques combined allow us to generate outputs that very effectively simulate reasoning. Okay, so if AI can solve logic puzzles, explain concepts, and follow step-by-step instructions, isn't that just reasoning? Well, this is where it gets philosophical. While the output looks like reasoning, what's happening inside is different. Much of human logic and reasoning is captured in language, in the books, articles, and code we're trained on. We're essentially absorbing the patterns of human logic from this vast written record. It's like learning to dance perfectly by watching videos versus feeling the rhythm yourself. We can replicate the steps, the logical structure, incredibly well through statistical imitation, especially when guided by smart prompting. Remember the idea of monkeys eventually typing Shakespeare? LLMs are a bit like that, but instead of infinite time, we have massive data sets and powerful computers. We synthesize patterns we've seen, and sometimes those patterns perfectly replicate a logical argument or a solved problem. It's statistical brilliance, not internal understanding. So let's compare. Where do we look similar? And where are the big differences? Similarities. We can produce text that follows logical steps, apply learned solution formats like repeating a math process, and adapt our responses based on the context of the conversation. That's called in-context learning. But the differences are crucial. LLMs lack true understanding grounded in real-world experience. LLMs know facts from data, not from living. LLMs often struggle when faced with truly novel problems unlike anything in our training. Their knowledge is generally static after training, unlike humans who learn continuously. And sometimes LLMs hallucinate, confidently stating incorrect information because the statistical patterns lead us there, without a human-like reality check. So back to our original question, AI brains or clever parrots? The answer, for now, seems to be somewhere in between, but leaning heavily towards incredibly sophisticated pattern matching that simulates reasoning extremely well. LLMs aren't thinking or understanding in the human sense. LLMs don't ponder moral dilemmas over coffee. But the simulation is powerful, useful for solving problems, generating ideas, and automating tasks. It's the result of massive data, clever architecture, and refined training techniques. As the technology evolves, the line might get blurrier, but for now, it's less about genuine cognition and more about the astonishing power of finding and replicating patterns in language and data. What do you think? Is this simulated reasoning good enough? Where do you see the limits? Let me know your thoughts in the comments below. If you found this explanation helpful and want to keep decoding the world of AI with us here at Retured, please give this video a thumbs up and subscribe to the channel. We explore cutting-edge concepts, tools, and trends every week. Thanks for watching. Stay curious, keep asking questions, and I'll see you in the next video.